Today we want to talk a little bit about statistical quality control, accuracy, precision, and baseball pitchers. This particular set of topics isn't directly in your book. However, there will be a couple of questions on this on the multiple choice thing leading into the final exam. Accuracy, precision, and baseball pitchers, statistical quality control. So, what is accuracy? What is accuracy? Accuracy is the ability to hit one's target, if you will. Think of it this way. There's the catcher's glove, a series of pitches are thrown at it, and can you hit the target? Well, in this case, they pretty much missed the glove all the time, but don't take it as the glove alone. Take it as the average. So, like, average those two, it's dead in the middle. Average that one and that one, dead in the middle. Average that one and that one, dead in the middle. Average that one and that one, dead in the middle. Average that one and that one, dead in the middle. So on average, they're really, really very accurate there. How about so that's good. How about this set of pitches? Well, it's more or less the same cluster, but now not so good. It was unable to hit the intended target. Precision then, not accuracy. Precision's different. What is it? Well, precision is the ability to hit near the same location over and over again. So here's our first target. There's a nice tight cluster of pitches, or shot cluster if you're thinking of it in terms of archery or something. Not in the glove except for a couple of them, but a very tight little set. Good. How about precision? Not so much. There we go. Spread all over the place. Actually, that one's relatively accurate, but it's not precise. Not so good on precision. So accuracy, where we want to be averaging where we were aiming. Precision is repeatability. And those two are very different in the manufacturing process. Let's take a look at that. Accuracy, we're going to measure by the average, by the mean. Precision, we're going to measure by the standard deviation. So the set of targets there on the left is what? It's quite accurate. The average of those four is dead in the middle. Look at the one to the right. Not so good for accuracy, superb for precision. So let's take a look at this and see if you can figure out the baseball pitches. Okay, here comes the first pitch. What do we have there? Poor accuracy, poor precision. Second pitch, what do we have there? How's our accuracy? Still not so good. How's our precision? Actually pretty good. Next pitch, what do we have here? How's our accuracy? Actually pretty good. How's our precision? Not so good. Okay, now they bring me in as the pitcher. Put up the target. Ready? Pitch. And boom. What do we have? We have both accuracy and precision. So here's one to think. If you were the baseball coach, which would you rather have? Well, of course, you'd rather have the one in the lower right, complete with that crazy pitch coming in. But what do you really get? Well, you probably get the one in the upper left, and they're not going to be playing professionally. But the two on the right, the poor accuracy, good precision, and good accuracy, poor precision, those could be actual professional prospects. And what can you do with each of those? Well, if you have precision, what do you have? You have repeatability. You have a low standard deviation. So maybe in the upper right-hand example, if you would move the pitcher over just a little bit to the right and maybe back up the release to be just a slight bit earlier, everything would look like the lower left. So that might be pretty fixable. How about the lower right? Good accuracy, poor precision. There it's going to be techniques. The pitcher can do it, but it's not regular. You have to be very careful about exactly where your foot starts exactly where the ball comes out of your hand and so forth, exactly your arm angle. So it's going to take some work, but there's hope for those two on the right. Now, how about applying this then to manufacturing? For example, the manufacturing of parts or the filling of containers, both of which we've had students in the past. The manufacturing of the parts, the gentleman worked at this, actually owned it. It was a car repair place that did some specialty work, and he would order some replacement parts from one place, and they were specified to be plus or minus so many thousandths of an inch. And then he would order the matching part, and that would have to come from a different supplier, and it was also guaranteed to be plus or minus a certain amount. And then the two parts wouldn't fit together, even though the specs said they both would. And what was happening? Well, if you were 10 plus or minus 2, so you could be at 8 with one part, and the other one might be 10 plus or minus 2, you might be 12, and the 8 and the 12 won't fit together, even though they were both supposed to be 10. That's one of your consequences. In the filling of containers, you've got a similar type of thing. You need to be filling at least to what the side of the bottle says to comply with the regulations. You can't sell 32 ounces claiming that for the bottle when there's only 31 in it. So that's, you want to have at least the minimum, but if you don't have precision, then you overfill, in which case you're just wasting product by putting too much in. So if the accuracy is off, like we just talked about, you have a type 1 error. You're putting the incorrect amount into the container. If your precision is off, then in order to guarantee the amount that the label says is in there, you have to overfill the container. So both of these are problems. Now, in some of your business classes, you may have already had some of the Six Sigma methodology. Well, they never really say that in Six Sigma, but what's Sigma? Sigma is the standard deviation. So what they're talking about is 6 standard deviations away from the mean. And it's a methodology for reporting things. And it's usually reported at the sigma level. So the higher the sigma, the better you are. So you can get all your processes within 2 standard deviations or within 3 standard deviations. And it obviously varies by industry. For example, the airline industry with their on-time flights. Well, what is 1 sigma? 68% of the pieces within the first standard deviations, or 95% within the second standard deviation. Airline on-flight times aren't even 2 sigma, are they? But how about if it was the amount of active ingredient in a prescription drug? Well, there you want to be very, very both accurate and precise. And so 6 sigma would be completely believable, if not even stringent enough for something like a drug manufacturer. Well, so what happens is there's this series of statistical measurements, CP, CPK, PP, and PPK, that can check some of those. The CP versions are process capabilities, and the CP is the capability, and the CPK is the index for that capability. And so you make adjustments to your CP for the non-centered distribution, and then the index number measures how close you are to the specification limits relative, that's why it's an index, relative to the natural variability of the process. So what you're really doing is measuring how close you are to your target, or how good your accuracy is, and how good your standard deviation is, how consistent you are around it. And then CPK is actually good. The indexing is good for short term. So what might we do? Well, we perform the minimum variation away from the target, and you get a lower CPK, and the CP will be high. Or performing on average exactly on target, you get variation in performance is high, gives you a lower CPK, and the CP will be high. The CPK will be higher when you're meeting the target consistently with minimum variation. So that's one set, the CPs. Now the other one is the process performance. And again, there's a performance indicator and an indexed indicator. And again, it adjusts for the non-centered distribution. So typically, actually, this will be specified like a CPK of about 1.1 1/3, which is 4 standard deviations. And you see this a lot, for example, in the automotive industry. Now, you've seen perhaps ISO 9000. That's the quality control standard. Uh, the auto industry actually doesn't use that one. They use the same thing over again with some different numberings that's strictly for automotive. But they will specify these kinds of things to their suppliers. So you want to machine cylinder heads for General Motors? Well, we want a CPK of 1.33 or better. The other thing just to take a note of in today's session is the registration is now open for both summer and fall of 2020. I don't know about you, but I certainly hope I'm going to be back to face because I'm not real keen on this online stuff. I like it much better in the classroom. But that's me. There's hybrids, there's onlines, and there's face to face. They're hoping for face to face in the summer, definitely for the fall. We'll see how it goes. Um, the fall semester itself runs the 24th of August to the 12th of December. As I mentioned, anticipated is face to face. I'll be doing one statistics class again. It's CRN 41103. As of the end of last week, there were still 23 slots open in that class. It's almost the same times as our one this semester. It's 1:40 to 3:30 Tuesdays and Thursdays. It might be in Falston Hall 208, not the room we were meeting in, but upstairs. But we'll have to see how that goes.